right. I'm Nicolette, and today Brian and I are here with Adrian Mikolajczak, VP at the Silicon Valley Innovation Center for Infineon. And we're going to talk about Infineon's role in driving innovation through collaboration and emerging technologies over at OktoberTech. So first of all, thank you, Adrian. We appreciate your time today.
Well, thank you. It's very nice to be here.
So why don't you just tell us a little bit about what OktoberTech is and kind of how it serves as this platform for showcasing innovation?
Sure. I mean, OktoberTech is a very cool event. It's really about technology collaboration. In fact, that's what we call it, Technology Collaboration Forum. And it's where we bring in our experts and technology and latest technologies, and we bring in our customers' experts and ask them to really get together and talk about what they can do together. So it is truly about exploring new potentials and what can be done with technology.
So how does Infineon go about selecting the companies that present at OktoberTech?
Sure, that's a great question. I think for us, again, one of our mantras for OktoberTech, because we're trying to explore where we can take technology, is it's if it's on the web, it doesn't belong at OktoberTech. And so whether it's our demos or it's partner demos, what we really look for is something that's innovative or that is new and it's pushing the envelope. And if it fits those kind of criteria, then it's a good fit for OktoberTech.
Do you guys provide some kind of support for these companies when they come to participate?
I'll maybe respin that question a little bit in the sense of, as both companies that participate there and our customers that come to this event, because it's really about the customers too. What we actively engage in and we actively strive to do is to bring, like I mentioned, those experts together and to explore there immediately at the event how that next generation can be achieved or what that next generation should be, in fact, right? So it's what kind of problems are you dealing with? What kind of challenges do you see? And then similarly, if someone sees a technology that just gets them jazzed, they can come back and say, could you take it here, could you take it there? And through that experience, the goal is that we then figure out how to take it to the next level.
Okay.
So that being the focus, Infineon is a very innovative company, and with our experts there, we really take seriously how we can solve these problems, and then after the event, how we continue to work with our customers and our partners that attended and explore how we can get things done.
So you talked a little bit about the next generation of technology being at OktoberTech. Now, what kinds of future technologies were highlighted at OktoberTech this year?
Oh, that's a great question. I thank you for asking.
Yeah, you're welcome.
I mean, we have a number of we had 90 demos out there to give you a sense.
So a lot of demos, yeah.
Yeah, and all these were focused again on new technology. But for example, in the keynote, we have system level demos, we have product level demos. But if I kind of start at the beginning, and what we highlight in the keynote, at the beginning, at the basic level, we innovate on fundamentals. Semiconductor technology. And so one of the things we showed, I'm going to grab a demo here, is a 300 millimeter wafer, which people have seen before. That's not unique. But what was interesting about what we showed at the show was it was the first 300 millimeter GaN power wafer.
Wow. Okay.
Which is cool. From the audience perspective, they may say, okay, that thing looks like a round disc. Nice.
I thought it was a mirror.
Yeah, okay, and it can do that, but it's a very expensive mirror.
Yes.
For that market. But what it enables you to do as you get bigger and bigger is you can basically drive down cost and get out more and more of those same kinds of parts into the world. And then similarly, some of the technology that goes into this makes things consistent and more reliable as you get larger and you improve your processes. So we'll get into what these ultimately make, I think, later here. But that's kind of the ground truth, if I may, where things start. Yeah. Yeah.
Do you have any other demos you could show us? I mean, you brought the wafer, which is cool. You have anything else?
Yeah, I do actually. So, if I look at our demos as a whole, we and our focus areas for technology, I simplify it for EMI so I can remember, but it's energy, mobility, and IoT. And And in each of those, as I said, we had over 90 demos. But like, if you look at energy, I'll be honest, energy is a little bit hard to get people excited. It's like showing the wafer. People go, okay,
Right.
I think that's cool. Is that hard? I didn't know. So here's an energy demo, and you can see it's super cool. I'm thinking everybody's getting already super excited, right? And what is cool about this, and what really matters about this, is this, in this case, happens to be a 2,000 watt power supply for data server farms.
Okay.
Okay. And you say, okay, that sounds cool, but the new technology, this is a silicon-based one, the new technology is this 3,000 watt one. And this 3,000 watt one, you might notice, is smaller, right?
A lot
By quite a
smaller.
bit.
Yeah.
And this leverages GaN technology, which I mentioned, that 300 millimeter GaN wafer. So this is leveraging GaN. And the other cool thing about it is that silicon one I showed you, the bigger one, is 94% efficient, and this one is 96. So, okay, why does that matter? Do I care? So both sound pretty good. If you think about a couple percent efficiency and you look at data centers across the globe, data centers are one of the fastest growing power consumers of the entire power grid right now. And so a few percent is not like, oh, I don't know, maybe, it's like, I didn't turn on the lights today. It's literally power plants worth of savings. We ran the math and we said, geez, if everyone, flipped to our latest devices where you're a few percent here, a few percent there, these percents add up and they're a big deal. And we're talking, multiple power plants worth of savings. So it's a big deal. More exciting than what a piece of metal might just generate if you think about what it really means. Yeah.
Right. So, okay, you talked about the GaN technology in the power supply. I just want to go back to the GaN wafer for a second. Is that like the biggest GaN wafer, like, ever?
That is the biggest production GaN wafer in the industry for power. Yes.
That's what I thought, because I was like, when he said 300 millimeters, I'm like, that's big, like that's a big wafer.
Yes, there are, when you go to traditional silicon and you go to like processor and these things, there are bigger diameters for sure. But when you go to power, there's specific requirements around power that make going very big, very hard. And then when you go to GaN specifically, and not just silicon, it gets really hard to make them big because of some of the thermal constraints and other things that make wafers bow and all this other kinds of stuff that makes it very hard. So this is really an industry leadership item. But I'll mention today, we actually, just talking about devices, we actually just today announced a newest, thinnest 300 millimeter silicon wafer too, which is pretty cool, which is thinner than a piece of your hair. Hair is, I think, about 60 or 80 microns thick. So it's a quarter of a hair in thickness. And that's, again, a big deal. You make these things so they don't crack and you can process them. And the reason people care, or the reason it matters, I talked about those efficiency numbers. You make them thick if they're conducting power. That's power loss. So you want to be more efficient, you need to be thinner, and so forth. So
and you said
that
the two power supplies that you demoed, the ones you just showed us, those were also GaN based, correct?
The first one I showed you, this one is a silicon-based one, and the other one was GaN. But actually, what we show a lot at the show is not just the individual technologies. I don't want to say, hey, look, always silicon, always GaN. Our most efficient solutions combine GaN, silicon, and silicon carbide, actually. Again, depends on the application and all these kinds of things. But by combining those is where you actually get the best performance, because each of these technologies has its sweet spot. And if you leverage them all, that's where you get the really cool outcomes.
So I have a question. The folks who created this, the wafer that you just showed, they come to OktoberTech. What are they hoping to achieve when they show this off there? What is the goal?
Yeah, so let's go back to, I mentioned, maybe before I answer it, we said what technologies. I said, energy, mobility, and IoT. And maybe I just touch on mobility and IoT as two other examples, and then I'll answer your question directly, because I think it'll give a better picture. So, for example, in mobility, one of the cool things we showed off, I don't know about you guys when you sit down in your car. A lot of us see screens all day long. I'm looking at a screen right now. I get in my car, there's a screen. And it's cool. On one level, it's super tech. On the other level, sometimes you just want something that's not a screen, right? And one of the cool things we showed off is actually for in the car, a touch-sensitive wood panel that looks like a wood panel. You sit down, in fact, it is a wood panel. It doesn't look like a wood panel. It's not faux wood. It's real wood. And then you flip on the car, and all of a sudden it lights up, and it is in fact a screen where it's backlit through the wood, and you can actually then touch and turn on your air conditioner and do all those things. But when you turn it off, it's pretty relaxing. You're like, oh, I'm in nature. It's beautiful wood.
Back to your wood dashboard.
Yeah, so it's very high end, very kind of luxurious, very kind of calming. And I think that's an innovation as well, right? Where you say, geez, I didn't know you could. In this case, we're actually projecting through wood, which actually turns out to be super challenging. The way wood diffuses, everything else, it's not an easy thing to do. We figured it out and we showed it off. So that's, for example, mobility. Another example we showed for the first time, we with a partner, we showed, for example, continuous lactate sensing. And lactate is something in your body, and lactate is something that kind of measures your physiological exercise health, these kinds of things. And we also showed glucose monitoring, which is tied to your dietary response. But going back to this, that was a super cool new technology because no one's done that. The way they measure lactate, they prick their ear today, and like an athlete will sit there on a bike and try to prick his ear to see what his lactate level is, see if he's exercising at the right level. That's once you're like Olympic level athlete. Now anyone can stick one of these in their arm, in theory, and measure and optimize their exercise. But that, going back to collaboration and your question of working together. That was a critical collaboration with our partner because making a lactate sensor requires a new sensor technology, which our partner developed, and it requires a sensor interface that can measure, picoamps of current, very, very small amounts of current, and very, very low, keep it very clean because the noise is, AC in your wall will start showing up in that sensor. And that we developed. So we developed a silicon front end that can measure these very low currents with a very low noise floor and actually see what's going on. They developed the sensor, and together we showed the first continuous lactate sensor in the industry. So that gives an example. And that's the kind of collaboration we do. And by showing those off, we hope that, at the event, someone looks and says, oh, I really like that wood panel, but, I'm not into wood. I'd rather see, I don't know, steel. Can you do it? Whatever it might be, right? And then we can go and explore that approach.
Okay.
Well, and with 90 demos, I find it hard for someone not to find something that'd be really, really interesting to them, right?
You can definitely find something. Yeah, exactly.
So now, Infineon also has a Silicon Valley Innovation Center, right?
Yes.
Can we talk a little bit about that?
Sure. I mean, I would say I kind of think of it this way: Silicon Valley Innovation Center. I should be able to say my own center very cleanly.
You're there now, correct? Right?
I am there now. Actually, in the backdrop, we have one of our just demo setups that shows. I think there's some quantum compute chips back there and some other things. But in any case, the company is very well tooled up to innovate in certain areas that we're in. Our silicon microphones, for example. There's a whole business line tied to that silicon microphone. You say, hey, I need a 5% better spec. I need something specific there. They are tooled up to go do it. The Innovation Center is tooled up to support kind of those next big ideas, those next big opportunities. So as a company, you're not sure how to solve a problem. You say, gosh, I really want to achieve A, B, C. I haven't seen anyone do this yet. I'm not sure how to do it. What's the right technology? Well, so what the Silicon Valley Innovation Center is designed to do is to really understand all the different pieces Infineon has to offer, which is a lot. I keep seeing new innovation pockets every day, and I've been here in, I think, 8 years now. And I still get surprised by things that different engineers and different parts of the company are working on. But we're here to really understand all that. And then when someone comes in with a tough challenge, to bring in the right folks or engage on ourselves and see if we can, in fact, figure out a solution for these customers. And that's what we focus on. So we do something called innovation dialogues, where we'll actually sit down, say, with a CTO of a company and talk about their next level challenges. And then, again, we will go off and explore, can Infineon help on that?
Okay. Yeah, I was going to ask, how does Infineon support, in this process? So that was answering my next question.
Perfect. Yeah, and I think it's an interesting opportunity too, because I think our customers really like that process as well. We've systematized it, and we really bring in, like I said, the strength of all of Infineon to look at some of these challenges. And I think we've been told it's a pretty unique process, and our customers do really appreciate it.
So now, Infineon, their expertise, right, has traditionally been semiconductor core technology. And how does this the Silicon Valley Innovation Center leverage these strengths to solve some of the system level problems?
Yeah, and I mean, the innovation at Infineon is pretty broad. I showed you a wafer as a starting point, but that wafer and the new technologies that get implemented through process improvements and these other things then bubbles up to spec performance differences in power devices, in sensors. The examples I gave you, that very low current measurement system, right, for lactate measurement. You need the right silicon devices to enable that. So these things cascade. And what's unique about, for example, engagement with Infineon is we have system level architects who can look at, say, how to build one of these, right, which has a lot of different parts in it. It's not just silicon, all the way down to the guys who invent the fundamental silicon. And so you can look at that whole chain and say, gee, what's the best way to, if efficiency is your thing, like in a power supply. I mentioned to you, our most efficient power supplies may have 3 different semiconductor technologies in them, right? So we can look at that, or they may even have some other technologies that we also participate in, right? And then inside those semiconductor technologies, you may be able to actually influence and change the device level structure, right? And achieve a next level performance there. In fact, we showed some of those. We had some breakthroughs. You know what? I'll hold at that, because I can get excited and talk about 90 demos, and that's not what everyone on the show was going to want to hear.
No, that's awesome. I mean, I have a question though. So we talk about these innovations, right, and these concepts. So how is Infineon and these companies working together to bring that concept into a real world application?
Yeah, no, that's a great question. I mean, I think, if I go back to that, the example with the lactate sensing, we started that development together, where it was a lot of discussion about, hey, how does that sensor need to operate? What are the trade-offs there, right? Oh, okay, if you make the sensor, there's a small needle that goes into your skin, and okay, you want to shorten that. What would that mean for noise figure? What would that mean for the actual sensor lifetime? And we debate those things, and we figure out together the best combination, right? So we built out the prototype. We brought it to OktoberTech. We showed it there. And now we're working together. We just launched a video on it to start explaining to the industry what's possible and what we've achieved. And now we're in the go-to-market phase on that, where we're actively engaging, customers together on implementing this in a final solution. So it's really kind of from the early discussion of what are the fundamental trade-offs with what they do and what we do, and then all the way out to taking it to market together.
So from when you start those early discussions, I would say on average, how long does it take from those early discussions to where you get sort of past OktoberTech to bringing it to market? How long would you say?
I would say there's no simple answer to that question. We have some of these, like we've had some of these dialogues, and someone tells us, we got a really tough problem, and we've been tackling it. We've been fighting with this thing for a year. And could you, I remember one discussion, could you change your Bluetooth solution to, and one of the experts in the room goes, actually, we have a register, and if you just flip this bit, it's done. So that was what, minutes?
Right. Yeah.
To some of these, like the medical topics, it can be 3-4 years. It can be more, right? From when you start a conversation to where you're actually putting something out in the market. So it's a very broad. And I think one of the cool things about Infineon and about OktoberTech is we try not to bias ourselves there, right? The goal is, how do we get this done for the industry, for our customer, and what's it going to take. And if it's an easy path, hallelujah. But the other cool part about Infineon is it has a very long view, and so if it's a big problem and it's going to take a while, that's okay too.
If there are any companies listening right now, right, or innovators, and they kind of want to know more about what it's like to partner with you, what advice would you give to them?
What advice would I give to someone who wants to partner with us? As I mentioned, we've got a lot of capabilities, a lot of really interesting pathways we can pursue. I think the key question we always try to understand with these partners and with these customers is, tell us really what you're trying to solve, right? If you already know that, you need the next 5% level performance in XYZ part, that's great. Then we can address that, and we have a whole organization that supports that in each of our product lines. Hallelujah. But if you really want to innovate with us, then talk to us about what you're trying to achieve, because we have so many different technologies and so many levels within those technologies that we can attack your problem, that we really want to understand what the end goal is. And we may come back to you and say, we thought this was a microphone sensor problem, but what we think actually the best way to solve it is maybe with an ultrasonic, or a radar, right? I mean, we've got so many different pathways that the better we can understand what you're trying to achieve fundamentally, the better we can come back and make a productive solution proposal for you.
I do want to shift gears a little bit and talk about Infineon's corporate mission for a second, because I mean,
yes.
Infineon is known for a strong focus in digitalization and decarbonization.
Yes.
So how do those goals really drive the new technologies over there?
Yeah, no, I'm happy you bring that up. So, I mean, if you look at even this example I gave you here, right? I talked about efficiency and improvement in power density. If you talk about I kind of say it again, like with my EMI, it's D&D, digitalization, decarbonization.
Mm-hmm.
If you talk about decarbonization, you're talking about efficiency. You're talking about eliminating waste, and you can see both on the efficiency side. We already talked about that. So many of the innovations we do in power are really driven by efficiency. And then the other half of it that's quickly forgotten is density. And this is a big, heavy brick, and there's a lot of items in here. But the smaller you can make it, it's the less metal you need around the casing and all these other kinds of things, the less magnetics you need. It just goes on. It improves kind of the limits the amount of waste that the industry creates, right, in trying to achieve these very important things like delivering power to a data server center. So I think that's one area. On the digitization, I mean, we've talked about that. Like the health example, now you can measure these kinds of key new things. You look at our IoT infrastructure, all the kinds of different things we do on communications, all these things really follow along the digitization path. So they're both really core to everything we do. The other thing I was going to bring up, one other thing that's super cool that we showed at OktoberTech was our product carbon footprint, and that is something I think is really neat. And you may say, okay, what is that exactly? And I kind of look at this as like when you go buy some food, there's something called a little food label that tells you what's in the actual things you're eating and so forth. And for us, when we talk about the decarbonization topic, what we've done is we've taken each of our parts and we've said, what level of energy consumption goes into these parts? And so there's actually almost like a little data label there that basically tells you, look, this much carbon equivalent went into, or CO2 equivalent went into the materials, went into direct emissions in the production, went into the energy to produce it, went into the transportation aspect of this. How much do we ship it around the globe? And so we can actually tell our customers what they're consuming. And we're really driving that in the industry so that people in the end can say, hey, this is the level of energy consumed, right? In the making of these products. And full circle to your starting question of the decarbonization topic in general. one of the things we're very proud of is when we track this, because now we can track it and we can say, hey, it took this much carbon CO2 equivalent to produce this part. But then we can also see what our parts do. And so when you talk about efficiency and efficiency gains by using these new parts, we've actually calculated out, because now that we have this data, it's actually kind of an easy calculation. And you can say, hey, we have about a 34-to-1 ratio. It may cost us 1x to make this, but when it gets in the field, there's a 34x reduction in energy consumption, so forth. Cool. So it's a net big savings. That's a cool part of the story, and I think that's drives a lot of people in the company forward. They really like that.
Yeah, I mean, I haven't really heard of any other companies like doing it, especially at that level.
We are pushing the envelope for sure there.
Yeah. Are you guys going to put, or is the plan to, or maybe you already do, is it on the packaging? Is it on the product itself, for instance, if it's, a brick or something like that?
Yeah, so we have a web page for it. I was going to say on this one, not a lot of people. I use the food analogy, but we're all consumers and we all go look at it. Here, by the time the package arrives, it's going straight into a pick and place machine, right?
Right.
But yeah, on our website we absolutely offer it up, and we don't quite have all our parts there, but we've got a good proportion of it, and we're growing quickly on how many we actually have. I think we're about 50% of our portfolio now has this, and that's I think it's www.infineon.com PCF, product carbon footprint /PCF.
That's pretty cool, because I mean, whoever's specifying, right, whoever's purchasing, they go there and look and check it out before they even go and make their purchases, that's really cool, actually.
Yeah, no, I think it's something we're definitely very excited about. We absolutely talked about OktoberTech, and we have a lot of customers who are starting to use it and appreciate it.
All right, yeah. I mean, I could definitely see engineers and like procurement people absolutely looking, when they purchase.
Cool.
So, Brian, is there anything else we wanted to ask Adrian before we close it out and thank him for his time and tell him to point us somewhere?
No, I mean, definitely point us where we could find the rest of the demos, because I'm really curious to see what else was at OktoberTech.
Yeah, so I think, again, OktoberTech is a collaboration forum. I mean, we've said it, we had 90 plus demos. We don't post them all because a lot of these are experimental and discussions, but we do have a website which we can send you that posts to that and shows some of the highlights, absolutely. And then I mentioned, I think as well, we launched a video on the health side of some of the stuff we're doing there, so I can share that with you. And then for customers that have these tough challenges and they want to engage with us on innovation dialogues, the SVIC website has contact information, or they can always reach out to me directly.
Awesome. Well, thank you so much for joining us today. This was fun.
Oh, my pleasure. And thank you guys.
Thank you, Adrian.